Okay, today we're going to be talking about section 8.3 in your book. This is t-tests. Okay, so remember from confidence intervals that when we're given the sample standard deviation, we use a t-critical value. So we're basically doing that same process again, but now applying it to hypothesis tests. So when we're given the sample standard deviation in this scenario, we're going to complete a t-critical value by looking at the t-chart. All right, let's take a look at a couple of examples. The same 6 steps apply to our process, so we're still going to be writing the null and alternative hypothesis. Step number 2, we're still going to be finding the critical value, but again, we're going to be finding the t critical value instead of the z. Remember that the degrees of freedom is found by taking the sample size minus 1. We're going to calculate the test statistic using the same formula, but instead of having sigma, the population standard deviation, we're going to have S, the sample standard deviation. We're going to find the p-value on the calculator using the t-test function. We're still going to be making the decision and summarizing the results. All right, here's the first example that we're going to take a look at together. It says, trying to encourage people to stop driving to campus, the university claims that on average, it takes people 30 minutes to find a parking space. I don't think it takes that long to find a spot. In fact, I have a sample of the last 5 times that I drove to campus, and I calculated the mean to be 20 minutes, and the standard deviation was 6. Perform a hypothesis test with alpha equal to 0.1 to see if my claim is correct. Okay, so step number 1, we're going to find the ho and ha. So the mean, the university is claiming that it takes 30 minutes to find a parking spot. I don't think it takes that long, so I believe that it's less than 30. Step number 2, drawing out the distribution. We're going to shade that left tail region because it's a less than scenario. And I'm going to look on my t-chart to find that critical value. Since I sampled, where's my sample size? 5 times I drove to campus, n equals 5. So my degree of freedom for this would be 4. Okay, guys, let's go ahead and take a look at the t-chart. For 4 degrees of freedom and an alpha of 0.10, I see a critical value of 1.533. I believe that's what that says, 1.533. But we do have a negative value because we're on the left side of the distribution. So my critical value is negative 1.533. Guys, my t-chart's a little bit different than yours just because I'm using one that's online, but it should be very similar, if not exact. Okay, step number 3, we're going to calculate the test statistic. It is going to be a t-test statistic instead of a z, but the formula is found in the exact same manner. So we take the sample mean, which was 20, subtract off the population mean, which was 30. That was used in our ho and our ha. We're going to divide that by the sample standard deviation, which was given as 6, over the square root of the sample size, which is 5. Okay, I'm going over here to my calculator. I am going to select the t-test, which is option 2, and I'm going to go ahead and enter that information. So the mean is 30, the ho. The sample mean was 20. The standard deviation was 6. The sample size is 5. And I have a less than alternative hypothesis. And calculate. So that t-test statistic comes out to negative 3.7. I'm going to round that to 2 decimal places, so 3. Taking a look at my distribution, negative 3 is going to fall out here somewhere. Step number 4, my p-value from the calculator is 0.0102. We're rounded to 4 decimal places. That is an extremely small probability, and since my test statistic is falling inside the shaded region, we're going to reject the null hypothesis. If I'm rejecting the HO, that means I'm getting rid of it, and so I'm in favor of supporting the alternative hypothesis. I'm not going to try to write out my summary statement, so I'm just going to say it. You would write this out. At alpha equal to 0.10, there seems to be enough evidence to say that it does take less than 30 minutes to find a parking spot on campus.